Hello and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of simple and compound probabilities. This is standard 7.6i in the great state of Texas, and we are using item number 28 off the 2017 released STAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So Rachel is setting up tables for a party, and we've got 4 of the tables covered with red, 8 tables covered with white. Guests are going to be randomly seated, and each table can seat 8 guests. So we need the probability that the first guest to arrive will be seated at there we go, red tablecloth. So let's see if we can draw these tables, and I'm just going to draw them kind of as larger circles. So that's going to be red. That's going to be red. And we'll just kind of do it like this. I've got 4 reds, and it looks like I've got 8 whites. And just pretend those tables are all the same size. And notice in that first row they got progressively smaller. All right, so I've got rows of 4 working here. And I'll just make another row of 4. And here we go. I've got 4 reds and I've got 8 whites, and I need to sit someone here randomly. So that is what we're going to call a simple probability. A simple probability is when there's one event. Just where's that person going to sit, at a red tablecloth table or a white tablecloth table. If you wanted a compound probability, what we would need to do would be to add another simple event on top of that, like what's the probability that someone would sit at a white tablecloth table and choose Coca-Cola to drink if there's like 4 different options or something like that. But we just have one simple probability here, and the only thing we haven't really dealt with here is the fact that we've got each table is the same size, or at least can and have the same number of guests. Right? So if we wanted to, we could just kind of put little dots here to kind of represent our 8 guests, right? And we could do that for all of them, but that would be a bit tedious. So I'm just gonna put a little 8 right here. So I'll just say we've got 8 guests sitting at all of these. What's the probability that our one guest that is going to be randomly seated will sit at a red table? Well, there are a few different ways that we can do this. So let me kind of show you the long way using this 8. So let's look to see how many places there are at the red tables. 1, 2, 3, 4. 4 times 8 makes 32. Out of how many total places there are altogether? Well, I've got 4, 8, 12 times 8. I've got 12 groups of 8. So that's going to be 96. So this is what I'm left with, is 32 divided by 96. So let's divide both by 8. See what we get. I get 4 over 12. Okay, I can divide both of those by 4. And I get 1/3. So I guess I could have just divided both by 32, and that would have worked, but I didn't know that 96 divided by 32 evenly. So we see our answer there is G, 1/3, but some of you might have recognized that this 8 guests, we don't really need that information. All we needed to know was that each table was the exact same size. And then once we knew that, we could just count the tables. How many red tables are there? 4. How many total tables are there? 12, which is what we got up there. We could have divided that by 4s, gotten to your 1/3. Or with the way I drew this, just take a look. If you happen to draw it like this, I've got 1 out of 3 rows that are all red. So our answer is G.